If you were taking a course in programming in C, you might be asked to display the phrase "Hello World" on your computer screen. This famous phrase dates back to an internal memo at Bell Labs in 1974 teaching people how to write simple C programs. However, if you look at your microcontroller board, you'll notice that there's no easy way to plug in a monitor, which makes writing the phrase "Hello World" as a first program actually quite difficult. When it comes to programming microcontrollers, there is a first program we can write that is quite simple and it tests functionality. All we have to do is blink an LED. This program, lovingly known as Blink or Blinky by embedded engineers, tests the basic functionality and is the microcontroller equivalent of Hello World. By doing this, we prove that we can compile code with correct syntax, run it on the microcontroller without any hiccups, as well as toggle voltage levels on pins. In the end, we know that we can dive into microcontroller programming and start building embedded electronics once we have this working. To start, I'll show you how to write a simple Blinky program. You can follow along by copying the code I write on the screen. This is the first step toward learning how to write your own Arduino programs from scratch. Let's begin. Take a look at your Arduino board. Most of the popular Arduino boards have an onboard LED connected to pin 13. If you have an Uno, like this one, you'll see an LED labeled L. This is the LED we want to make blink, and it's electrically connected to pin 13 through a series of copper traces on the board. To give our Arduino power and send our compiled program to it, plug in a USB cable to the USB port on the side of the Arduino. Plug the other end into an available USB port on your computer. Open the Arduino program. Select File, New to make sure we are working with a fresh sketch. You should see two blank functions already started for you, which act as a template every time you go to write a new Arduino program, which is also known as a sketch. Everything you write between the curly braces of the setup function is run exactly once as soon as the Arduino board boots. Once your setup code is run, the program then runs everything you write between the curly braces in the loop function. Because it's labeled loop, the code is run again and again forever, as long as the microcontroller has power. Note that every Arduino sketch should have one and only one setup function and only one loop function, even if there is nothing between the curly braces in those functions. To blink our LED, we first need to tell the Arduino that we want to control the voltage of pin 13 using code. This is known as setting the pin as an output, and we do that by writing the following line of code in the setup function. Pin mode, open parentheses, 13, comma, output, close parentheses, semicolon. Note the capital M in pin mode, as this is a special Arduino function that we're calling to set the mode of a pin. We specify pin 13 as our first parameter, since that's the pin number whose mode we want to modify. We then write the word output in all capital letters to denote that we want our pin 13 to be an output mode. It's in all capital letters because it is another special constant known by the Arduino system. If you changed any of the letters to lowercase, you would not be able to compile your program. The semicolon at the end of the line is very important. In C and C++, it marks the end of a statement. Without it, the compiler will likely fail when it tries to compile, and you'll get an error at the bottom part of your Arduino program. We can leave the line with the double slash. It is a comment and will be ignored by the compiler. Now, move to the loop function and write digital write, open parentheses, 13, comma, high, close parentheses, semicolon, in between the curly braces. Similar to the pin mode function we called earlier, this function tells the Arduino that we want to write the value high to pin 13. In the case of our Arduino Uno, this will cause pin 13 to go from 0 volts to 5 volts, which is enough to light our LED. Then, underneath the digital write function, write delay, open parentheses, 1000, close parentheses, semicolon. This is another function we call to have the microcontroller do nothing for 1000 milliseconds or 1 second. Under that, write digital write, open parentheses, 13, comma, low, close parentheses, semicolon, which tells pin 13 to go from 5 volts to 0 volts, turning off the LED. Finally, write delay, open parentheses, 1000, close parentheses, semicolon under that. This will force the microcontroller to wait another 1 second. Because these 4 statements are contained within the loop function, as soon as the microcontroller runs each one in sequence, it immediately starts at the beginning and runs them again over and over and over. We now need to tell the Arduino program which board we are using and on which USB port it can find it. Select Tools, Board, Arduino Genuino Uno. Then select Tools, Port, and whichever port appeared by plugging in the Arduino. For me, this was COM4 on Windows, and it might be /dev/cu.usb serial some letters and numbers on Mac OS. Press the Upload button, and you will be asked to save your program. You can choose to save your work with a name like Blinky, or just press Cancel. Either way, the Arduino program will compile your code and automatically send it to the Arduino board. You should see the phrase Done Uploading appear just above the status pane. If you see any errors, carefully read the error messages and compare your code to the code presented in this lecture. Assuming the compilation and uploading process went smoothly, you should be presented with an LED that pulses on for 1 second and off for 1 second. In later lectures, we will attach LEDs, buttons, and various other electronics to the available pins on the Arduino board. This will allow us to do things like create fun light patterns, accept user input, read sensors, and control motors. One cool thing about microcontrollers is that they are designed to continue running your program even if they are not attached to a computer. So, if I plug my Arduino into a battery that provides 5 volts, it will run the last program I uploaded to it, which is Blinky in this case. Just note that some of these phone charger batteries will automatically turn off if not enough current is being drawn from them. Getting to Blink is a very important first step, as it proves you can compile code and run it on your microcontroller. In fact, I highly recommend you run this simple program every time you receive a new microcontroller or Arduino platform. Once you know it works, you can begin developing on it.